All right, so let's go ahead and get started. So we're graphing on a polar axis. So a polar axis is circular. So when you're graphing on a polar axis, the first number is your radius, and the second number is your angle. So what this means is I'm going to 90 degrees, and then I'm going out to a radius of 4. So 90 degrees would be this axis right here. And then every circle represents a radius. So the fourth ring, so 1, 2, 3, 4. So right there, go ahead and put a point and label that A. So that's where point A would be. Point B, go ahead and locate 210. So 210 degrees. Oops, okay. So we're rotating. So 210 would be here. This is 210. And you're going out to the third ring, which would be right here. So your negative. So let's talk about a negative and how to do a negative. So when you're doing a negative, I want you to ignore the fact that it's negative, okay? And I just want you to plot the point positive 1, 120. Or don't plot it, but figure out where it would be. So positive 1, 120. So this is 90. So 120 would be this axis right here. Positive 1 would fall right here. But because it's negative, you're going to push it back. So it like reflects. So it reflects across the origin. So it's going to land right there. So when it's a negative, it reflects over the origin diagonally. Okay? So that point, negative 1, 120, so negative 1, 120 is going to fall right here. Oops. 60, negative 3. So 60. So this is 30, this is 60. So positive 3 would be 1, 2 would be right here, right? But you're going to reflect it, so it's going to go to there. Okay, so you're going to reflect it backwards 180 degrees. So 60 would be on this axis. So this is my 60 degree. So instead of it being on this third ring, we're going to go backwards. And it's going to land here. Okay, negative 330. So negative 330, we're going clockwise. And you can use a calculator now. So if you would prefer to have a positive angle, go ahead with your calculator and add 360 to it. Because remember, adding and subtracting 360 gives you coterminal angles. So you can also, if you would prefer, to work with a positive angle, you could also call that point negative 2.5, positive 30, because that's the same angle. So positive 30 would be here. So negative 2.5, I'm going to go backwards. 1, 2, and it's going to fall right in front of point B. So it will be right there. So negative 2.5 would be halfway between the second and third ring. So that will fall right there in front, which would be here. Negative 45, this is negative 45. Again, if you want to add 360 to it, this is the same as saying positive 5. And then you could also add, and that would be 315. So 315 would be this axis right here. And you're going out to the 5th circle, which will be right there, right on the edge. Go ahead and see if you can plot point G by yourself. Negative 2, 180. So 180 is this axis here, right? But if it was positive 2, I would go to this. I would go to the positive side. But because it's negative, I have to reflect it. It's going to land right there. So this is where it's going to land, right here. So that would be point G. All right. So let's go ahead and look at our next example, which is in radians. And if you want, you can always convert it to degrees. Your project will be in degrees. We'll talk about the project next Thursday. But if you want to work with degrees, you need to multiply by 180 over pi. Now, I'm going to keep it in radians, but you have that option to do that if you would like to convert it to degrees. So 5 pi over 6. So I'm counting by 6. So this would be 1 over 6, 2 over 6, 3 over 6, 4 over 6. So 5 pi over 6 would be right here. And now you need to go out to the third ring. So that would be 1, 2, 3. Go ahead and put a point right there. That would be point E. Two pi over 3 is the same as 4 pi over 6. So that would be 1, 2, 3, 4. So this is 4 pi over 6, which is the same as 2 pi over 3. Now this is a negative 2 though, right? So instead of me going forward, I'm going to travel backwards. So I'm going to land right there. So that would be point F. (180 degrees would be this here. So this is 180 going out to the fourth ring. 1, 2, 3, 4. So that would be right here. And that would be G. So when we're talking about 3 pi over 4, so this is 1 over 4, 2 over 4, 3 over 4. That would be right here. But because it's a negative 2, I'm going to go backwards 2. So 1, 2 would be right, right there. And that's where H would fall. All right, take about 3 minutes and try to do I, J, and K because you have to practice graphing. So graphing polars will be on your final, and again, that's the basis of your project. So you need to practice. So go ahead, take a couple of minutes, see if you can plot I, J, and K, and then I'll plot them. you, girl. You saved my life. So 11 pi over 6. So I'm counting by 1 over 6. So this is 1 over 6. Again, you can multiply this. If you don't want to work with radians, you can convert it. But I'm just going to keep it in radians. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 pi over 6. And what's the radius? So go out to the third ring. So 1, 2, 3, that would be right there. So F, H, and I are all real close together. So I would land right there. This would be I. Pi over 6. This is pi over 6. But it's a negative 4. So if it was positive 4, I would go out. But because it's negative, I'm going to count backwards. So 1, 2, 3, 4, that would be right here. So who had point J right there? Good. Let's go ahead and plot that right there. And then lastly is K. So negative 3 pi over 2. Negative 3 pi over 2. That would be this axis here. So negative 3 pi over 2 is the same as negative 270, which is the same as positive 90. So this is negative 3 pi over 2, but I need to go backwards 5. So that would be right here at the edge. All right, who had those 3 points in the right spot? Any questions about that? Because again, we're just going through the notes to prepare you to do the project. You will have this on the final, but you're not taking a test over polars. It's just on the final exam. But your project is based on polars, and the project grade does go into the test category. So it's a chance for you to show what you know without having to do a test. So now, let's go ahead and name these 2 points. And with polars, it's not like a rectangular coordinate plane where you can only name a point one way. You can name these points multiple ways. So I'm going to call this one point A. So let's call this one A and this one B. And let's work through A together. So we're going to name this 4 different ways. And we're only going to do it in degrees because I know most of you are most comfortable with degrees. Okay, so the first thing, if I'm calling this, if I want to name this point, I can name this point really more than 4 ways, but we're going to do it 4 ways. So first of all, what angle does this represent? And we'll do a positive angle. So if I rotate counterclockwise, what would this angle be? What is it? 150, or you can do radians. So I'm going to just do degrees. So this will be 150 degrees. And then what ring does this fall on? What's the radius? 5. So this is 5 away from the origin. 1, 2, 3, 4, 5. That would be one way to name point A. Let's name it another way. Now let's talk about a negative angle. So if I were to rotate clockwise, this would be negative what? And if you're not sure, you get to use a calculator. So you could take 150 and subtract 360 from it. What'd you say, Aiden? Negative 210. Yeah, so that's another way to name that. And it's still on the 5th ring. So that's 2 different ways to name this point. All right, now let's use a negative radius. So if we use a negative radius, that means that we would use this as my reference. So this, what is this angle going to be? 330. But in order for it to land here, my radius has to be negative. All right, so that means in order for me to land here, that means I will have to rotate to 330. And then because I would have to go backwards 5 to get to this destination. So that would be a negative 5. And then also I can name this as negative 30. So I can use a negative angle and a negative radius. All right, I want you to try to do point B by yourself. Name that point 4 different ways. So let's just do it the easy way first. So the easy way would be to name this angle as a positive angle. So as a positive angle, this would be 210, right? And what ring are we on? 3. So that would be the easy way to name it. Oops. Okay. So now let's talk about it as a negative angle. So what would this angle be? Negative. So if I go clockwise, that would be 90 plus 60, which is 150. So that would be negative 150. Who had that for 2? Okay. Now, for us to use a negative radius, that would mean that my reference would be here, which is 30. So I could also name this point as negative 3, 30. Or I can use a negative angle. So what would this be as a negative angle? Negative what? So I could also say negative 3, negative 330. That's 4 different ways. All right, who had all 4 of those? Any questions about that? Yes.
Okay, so how do you put the second and fourth one?
So this one here. Wait, this one here. So you can always subtract 360. So going back to the unit circle, angles are coterminal when you add or subtract 360. So if you take 210 minus 360, that would be negative 150. So that would be another way to name the angle. And when we did our unit circle, you weren't allowed to use a calculator to add and subtract 360, but now you can, so that could make it, a little easier. All right. So now let's go ahead and graph. So when you're graphing a radius, oh man. When you're graphing a radius, that looks like a circle. So when we're graphing a radius, that's a circle. That's what that's going to look like. And when you're graphing an angle, that looks like a line. And there's multiple ways to name. So there's a lot of different ways to name an angle. And we'll talk about that. But a circle is just a circle. Okay? So for part A, when it asks you to graph r equals 2, you're just drawing a circle because it's a radius. This says graph a radius of 2. So go out to your second ring and you just draw your circle. That's how you graph r equals 2. Now 2 pi over 3 is the same as 4 pi over 6. So 4 pi over 6 would be 1, 2, 3, 4. So right here. Now you're actually going to draw it through the origin. So I know that 2 pi over 3 is just here, right, on our unit circle. But when we're graphing it on a polar axis, we actually draw that through the origin. So that's why it looks like a line. And there's multiple ways to name that. 2 pi over 3 is just one way. And we're going to practice that here in a second. Negative 7 pi over 6, so you're counting backwards and counting by 6. So 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, 7 over 6. So this is where we would land. Except you go through the origin. And that would be your graph. So the last thing we're going to do is name equations for a graph. So let's start with this first one. So this is a line, right? So there's two different ways we can name it. We could focus on this end. So what would this angle be? So we're counting by 30s. This one doesn't have the 45 marks. So we could call this 30, 60. So this would be theta equals 60. That would be one way. Okay. But remember, there's two different. We could also name this piece. So what would this angle be for this one? $240. So on a polar, theta equals 60 and theta equals 240, they're the same. Now we can also go negative. So you can use your calculator if you're more comfortable doing that, that's okay. So if you want to take 60 and subtract 360, that's going to give you negative 300. So in your calculator, go ahead and subtract. So take 60 minus 360 if you need to use a calculator. 60 minus 360 will give you theta equals negative 300. And you could also do 240 minus 360, which will give you theta equals negative 120. So again, that's 4 different ways to name that. Now for a circle is a circle. So the only name for this would be a radius. What's the radius of this circle? So that would just be r equals 4. All right, go ahead and go to the next page and do those last two by yourself, and then we'll go through the answers together, and that's it for today. So for C, the rate is the circle, so that's pretty simple. That's just R equals what? R equals 2. So that's simple enough. All right, so there's 4 different ways, actually more than 4. We're just naming 4 ways. So the first way would be theta equals, so this piece here that's in quadrant 2, what would be the measure of that angle in quadrant 2? That is, see, 90 plus 30, so 120. So who had 120? Okay, so theta equals 120. Now, if you take your calculator and subtract 360 from that, you will get negative 240. So that's 2 ways to name this piece that's in quadrant 2. Now, the piece that's in quadrant 4, this piece, that could be theta equals what? 300. Or as a negative angle, that would be what? Negative 60. And that is your introduction to polars. All right, again, I will not be here Monday. Make sure you watch the video. It's going to explain how to graph on a polar axis to help you prepare for your final project and the final exam.